Hello, everyone. Okay, so this will be video number 3 on lists. Okay, so on the first video on lists, we defined them, we did some methods on them, slicing, indexing, um, um, concatenation, other things like that. You can see this in the first video. On the second video, we expanded on nesting lists and how to create matrices and how to index and pick up like certain rows and items in the lists. And today is the third video on lists, and I will start with comprehensions. Okay, comprehensions on lists. So in addition to the sequence operations and the list methods that Python has, it also has a one more advanced operation that is known as a list comprehension expression. Okay, list comprehension expression, and I will go through some of this now. So this is a very powerful way to process structures such as matrices. Okay, for example, let's get down to it. So remember, last time we have a matrix M, 3 by 3. First row is 1 2 3 4 5 6 7 8 9. And recall last time we said that this is a list. This is nesting lists within a list. So within the overall list, there are three lists inside that first list, and each one of those three lists represent a column in the matrix. Okay, and by the way, if I remember correctly, now notice when you print the matrix, you get it in such a manner where you have a list of lists, but then it's not laid out like a matrix, right? So there's a way, if I remember correctly, where you can actually import, so you can print it out in a nice mathematical form. What you can do is you can import matrix. I believe the name is matrix from NumPy. Let's see, from NumPy import matrix. So let's do that. From NumPy import matrix, and then if you do matrix M, so matrix and then the argument is M because I called it M. Okay, let's see if it's gonna do it. Is it? Yes. So you can see now, rather than printing it the way, like three rows next to each other, which is a little bit confusing to the eye, because this is the way where you were used to seeing matrices like this: row and then another row underneath it and then a third row underneath the second row. So it gives it to you in a nice print format. Okay, so this is a function in NumPy. You import it and then you can use it, and then you can see that in there. Okay, so let's go back to comprehension expression. So let's say, okay, one of the applications of this is, let's say, last time we said that we can grab rows by simple indexing, right? Because the matrix is stored by the rows. So if I do M1, I'm gonna get the second row. If I do M0, I'm gonna get the first row. So M0 is 1 2 3. That's the first row. And then if I need the second element in the first row, I would do M0, and then I would do the first element would be number 1 in that list. So I would do M01, M bracket 0 bracket 1. That's going to give me element number 2 in that matrix. Now, so we already discussed this last time. So let's say I need to let's say I need a column, okay, with a list comprehension. How do I do that? Let's say instead of wanting, like, say, row 1 or row 2 or row 3, suppose that I want column 2. Okay, so what I can do, I can collect the items in column 2, and the way I would do that, I would say, watch this. So this is column 2. I'm gonna call it, let's just say C2. Okay, C2. So I'm aiming for column 2. So I can say this is a list. Okay, and I need to grab row 1. Okay, so I'm gonna grab column 2 now. So row 1 will give me, row 1 would be row 1 would be this, the 1 2 3. Okay, so row 1, okay, but then I need column 2, so I need the 2, 5, 8. Okay, I need the second column in the matrix. So if I do row 1, I will get 1, 2, 3. Okay, but then I would say for row in M. Okay, and I'm gonna show you what this is gonna print. So if I print C2, I get column number 2, which is 2, 5, 8 in the matrix, in this matrix M. Now, what happened here? So let me elaborate what happened here a little bit. How were we able to do this, right, is the question. So basically, row is the variable here. And when I say row in M, I am talking about the variable in M. So I am telling Python now to go for each row. So row 1, row 2, row 3, okay? I am telling Python, go to row 0, and that would be the first row here, okay? And then grab me. So now remember, row is the first row, the first list. Grab me from that list row 1. Row 1 would be, so 1 would be 0, and 2 would be 1, and 3 would be 2. So grab me element item number 2. So that's row 1. Okay? So that's for row, so it grabs the 2 for row 0. Then, since I'm using a for loop, I will talk about loops later, but for now, it's gonna, so it's an iterative way, okay? 4 steps, 4 kind of iterates over every row in M, okay? It's a sequence. I have a sequence of lists. List 1, row 1, list 2, row 2, list 3, row 3. So when I use for, I am telling Python to go through each one of those lists. So now when it steps to row 1, okay, so now we're at list 4, 5, 6, and it's gonna grab element number 1, which is the second element in 4, 5, 6, which is 5. And then similarly, it's gonna do it, and then it's gonna go back. Now row is the third row, 7, 8, 9, and it's gonna grab the first element in that row, which is 8. And that is how we get 2, 5, 8. Very important. Now notice, if I print M, the matrix is unchanged. It's still the same. Okay. So basically, this list comprehension means what it's saying. It's saying, just to summarize, it's saying, give me row 1, okay, for each row inside my matrix M in a new list. Okay, so the result is a new list 2, 5, 8. Okay, now these list comprehensions can be more complex, so you could do more stuff to them. I will cover some of these things after we go through the loops. Okay, so let's postpone that for now. Okay, now let's say I want to collect a diagonal for the matrix, right? Let's say I want the diagonal element. So let me just call this the diagonal. Okay, and in this matrix, obviously, the diagonal elements will be the elements lying across the diagonal. So that would be 1, 5, 9, right? So how can I do that? Well, I can also make a list, and I can use a for loop again. And now I would say, okay, give me recall. Sorry, 1 second. Recall. The first index picks up the first list, which is the first row in the matrix, and the second I picks up the item number in that row, in that list, okay, in that row for the matrix. So that means every time I changes, notice that I is the same here. So if I is 1, the second I is 1. If I is 2, the second I is 2, which is nice, right? Because what that means, if I say here for I in, and I have 3 rows, right? In 3 rows, so I could say in 0, 1, 2. So that means I am using an iterative tool through a for loop that will pick out exactly the same item location in the same row, which is what that diagonal element is. So in other words, if I is 0 here, okay, it's gonna give me m00, and m00 is 1, as we said. The 0th row, the first row, and the first element in that row. And then it's done, and then it goes back. Okay, so let's print it first so you can see it. So if I print diagonal, and look at this, it prints 159. Okay, so we've already explained the 1. So now the 4 is done with the 0, then it goes back and it picks I equals 1, right? Because it's a loop. It's an iterative process. It's iterating over 0, 1, 2, okay? 3 different times. So now when I is 1, this will be M11. And M11 means the second row and the second element in the second item in the second row, which is the 5, okay, which it prints here in a list. And then similarly for I equals 2, that's M22, so that's the third row and the third element in the third row, the third list, which is the 9. And that's how we get 159. Okay? So, the last thing I want to discuss here is I could, let's say I want a list of numbers, right? So I could use things like range, which is a built-in that generates successive integers. Very important. So if I say give me a list of range 5, okay, it's gonna give me, and then I print it, it's gonna give me a list that has the numbers starting from 0. The default is 0. If I don't specify it, it's 0. Okay, it doesn't have to be 0. I could have said 1 here. Okay, if I do 1, it's gonna start with 1. You can see 1, 2, 3, 4. If I say 2, so the 1 is the left, the left item in the list, and 5, it's gonna go all the way up till 5, but not including 5. That's very important with the range, okay? And it's gonna step in multiples of in integers. It's gonna add 1 to each subsequent integer. So 1, 2, 3, 4, etc. Now, why is that? Because by default, the third argument in the range is 1. So you don't have to put 1. But again, it doesn't have to be 1. See, if I put, like, let's say 7, and then I put here 2, that means I am telling Python to generate a list of numbers between 1 and 7, excluding 7, including 1 but excluding 7. You always include the left bound, but you exclude the right bound. But this time I want it to be in increments of 2. Okay, so it's not gonna list them consecutively. It's gonna skip 1, and you can see if I print, it's gonna be 1, 2 is skipped because I have 2, 3, and then 4 is skipped, and then goes to 5. Okay, and then 6 is skipped, it goes to 7, but remember 7 is excluded by default, so it's going to give you a list of 1, 3, 5. Okay, so this is a very powerful argument in there. And by the way, the range also doesn't have to start at a positive number. I could have made this -6, and it's going to start at -6 and increments by 2 all the way up to 7, but not including 7. Okay, now you can also do multiple values if you want in terms of a list. So another very neat way of usually creating the list, if you know what your list is, okay, let's say you're trying to create squares. So I can say, okay, give me a list, let's say x squared, okay, x squared, 4x, again, we are iterating now, 4x in range 4. Okay, so if I only enter one argument for the range, that means I'm, by default, my left argument is 0 and my increment is 1. Okay, so this is gonna pick values 0, 1, 2, 3, excluding the 4. So now I'm telling Python to give me for each x in that range. So x is gonna pick up values 0, x equals 0, and it's gonna spit back x squared, 0 squared, and that would be 0, the first element in the list. You can see the output here. And then it's going to go back and do x equals 1, and 1 squared is 1, so that's the second item in the list. And then 2, 2 squared is 4, third item in the list, and then 3 squared is 9, and that's the ninth element. That's the fourth element in the list. Okay. I think that is it. I might have a few more things to say on the lists. I will do it next time. And then we will start the dictionaries. So we'll see. I'll either do a video or we'll go directly to dictionary, and either way I can discuss it there. Thank you for watching. I hope this helps. This was lesson 3 on lists. Please don't forget to subscribe, like, and if you're able to, help us and fund us to keep this information coming and continuing and free for the public, for everyone to take part in and benefit from. Please don't hesitate to fund us on the email address I have, PayPal address I have in the description. Thank you for watching and have a great day.